Good afternoon, everybody, and thank you for joining us for the DHC Talks. It's already the ninth edition of the DHC Talks series, which is a series of webinars that the DHC Technology Platform decided to bring to you during the difficult Corona lockdown. For some of you, the lockdown is probably already over, but many of us continue working from home. And what we want to do is to give you a break from the home office routine and probably your childcare routine. So sit down, relax, grab your favorite tea or coffee mug, and let's talk about upgrading heat distribution and piping technologies. This webinar is also part of a series of public UpgradeDH webinars, and this is the second one that Projekt UpgradeDH brings to you. Just a few words about the organizer. My name is Aksana Krasatsenka, and I work for Euroheat and Power. Euroheat and Power is the international network for district energy, promoting sustainable heating and cooling in Europe and beyond. The DHC Technology Platform is the research and innovation hub of district heating and cooling. Together with our members who come from academia, industry, and national district heating associations, we promote research and innovation in district heating and cooling. We provide them with networking opportunities. We organize together educational programs. We represent the interest of district heating and cooling sector towards European institution, and we gather the available knowledge about district heating in our knowledge hub. EU projects are a cross-cutting element in everything we do. And UpgradeDH is one of the very important projects that brings very valuable content for us to discuss. So as I said, this is the second UpgradeDH webinar. During the first webinar, we talked about non-technical aspects of upgrading district heating and cooling systems. We touched upon stakeholder engagement, contracts, and business models. Today, we will deep dive into technical aspects of district heating retrofitting. And more specifically, we will talk about the veins of district heating. I had a very interesting conversation with our communications person at Euroheat and Power, and also native English speaker, who was a bit concerned about my choice of words. But I managed to convince him that district heating pipes are actually the veins of district heating. Just looking at the definition, any of the tubes forming part of the blood circulation system of the body. The body in our case is a district heating network of a city. And these tubes are carrying blood towards the heart, and the heart being our district heating customers. So figuratively speaking, essence of district heating systems. And today, I'm happy to talk about this topic with our speakers. The first one is Matteo Pozzi. Matteo is participating in the UpgradeDH project. He is CEO and partner of Optit since 2010. After a degree in physics and more than 15 years in management consulting, Matteo is a big fan of digitalization and advanced analytics application to business processes. He's trying to build a better and more sustainable world. The second speaker will be Evaldas from the Lithuanian District Heating Association. Evaldas also is actively participating in the UpgradeDH project, and he is energy technology and economics analyst at the Lithuanian District Heating Association. Then we will hear from Sebastian Grimm. Sebastian has a master in mechanical engineer. He is working for AGFW, the German District Heating and Energy Efficiency Association, and more specifically for its research and development department since 2016. His research topics include digitalization, district heating pipes and systems. And I also have the pleasure to know Sebastian since 2016, when he participated in the 4th DHC Plus summer school in Warsaw. And finally, we will hear about an external expert, Peter from LOGSTOR. Peter is a product and academy manager at LOGSTOR. He's educated as engineer in Aalborg University in Denmark. And what is interesting is that he started working for LOGSTOR in 1992, which means that he is a very loyal employee of LOGSTOR. My name is Aksana Krasatsenka. As I said, I work for the DHC Plus technology platform. And just to respect the tradition of the DHC Plus talks, I will ask all our presenters to switch on their webcams. I will do the same. And as a tradition, we all would like to show you our favorite coffee or tea mugs and say a few words. So I will start. My mug today is very colorful. It's got a lot of flowers in it, and it's called Garden Blossom. We had a very sunny lockdown period in Belgium, and all our gardens are blossoming now. Unfortunately, today is a bit grayish, but with this mug, I just want to bring you good mood and good emotions. Then I'll ask Matteo if you can say a few words about your favorite coffee or tea mug.
Yeah, I've got a very old mug that dates back to my Erasmus time in Bristol, University of Bristol, so we're speaking about 25 years ago. And that's when I decided to mix my analytics skills with the fact that I wanted to work with people, and that brought me here. So in a way, it's a good starting point.
Thank you, Matteo.
Also, it's empty because it's too big for coffee that has to be drunk hot.
Exactly. Then I will ask Evaldas to say a few words.
This is my favorite coffee and tea mug. I actually bought it 4 years in Crete, so it actually reminds me sun and beach and holidays, of course.
Everybody's thinking about the same now. Thank you, Evaldas. Sebastian?
Yeah, thank you very much. So I brought my favorite coffee mug, which has an emblem of my hometown on it. It was a present of my colleagues. And what is very important is it has my name written on it. So if I have it in the shared kitchen room here, I will find it all the time again. So this is kind of very important back in the office.
Exactly. Thank you, Sebastian. And Peter? Peter, you have to unmute yourself.
So this is my favorite coffee mug, the LOGSTOR coffee. It's black and it's hot and it's strong.
Great. Thank you very much for these insights. And now we will turn off our cameras and let our first speaker, Matteo, start with his presentation. Thank you very much.
Please confirm that you see my screen.
Yes.
Here we are. Very good. So Aksana asked me to introduce the UpgradeDH project for everyone's benefit, and I will spend a few words on it. It's a project that concentrates on the upgrading process of the performance of district heating networks in Europe, and it does so by spanning through a vast range of systems in Eastern European countries, Central European countries, and Mediterranean and Balkanic countries, ranging, spanning through the whole value chain, namely production, distribution, and consumption. And it puts together interesting but also actionable best practices, tools, options for the upgrading process of existing district heating systems. There's also a very well done handbook, and right now a district heating image raising campaign has been launched, which I'm sure Aksana will tell us about at the end. The project is now in its at the beginning of its third year and last year. So we've got a good range of interesting options that have already been tested, and we are happy to see that the pretty ambitious objectives of improvement on primary energy demand and greenhouse gas reduction are likely to be met, and we are getting in the definition of potentially regional national action plans, looking of course at replicability. This public webinar is one of many opportunities to bring you the know-how that has been developed by this very interesting consortium. And in any case, in the slide, there's also the website, which I would point you to because it's a good source of interesting material for that. And let's dig into the subject. For those who do not know me, I'm the CEO of Optit. We are a spin-off of the University of Bologna, and we develop solutions based on optimization and mathematical modeling and advanced analytics. We integrate data scientists, consultants, and software engineers to bring optimization to the field. As you can see, together with UpgradeDH, we are also active in other European funded projects, planning multi-energy systems, while Retrofeed, the one at the bottom, is actually on improving the energy efficiency in energy-intensive industry. So we are really trying to couple sectors and know how to build a better future. But we know that today we're speaking of improving the distribution system. And speaking about decision support, there are lots of difficult decisions to be taken looking at district heating network. There are very hard and difficult investment decisions with very large investments, potentially not a big deal of data, lots of possible alternatives, and that also mixes with long-term planning that may be more focused on tactical and commercial development, or the analysis of bottlenecks or problems with the network. Of course, then there's also a big area of decision making, which goes in the short-term planning, how to dispatch heat, how to optimize temperature, just to name a few, down to operational, that goes in monitoring and control of network parameters and pumping optimizations. Today, we are focusing on the upper part of the chain, even though I must say during the UpgradeDH project, we also had good examples of actions on the optimization of short-term and operational planning, for instance, using tools like permits. So we speak about strategic and development optimization, and that means how to decide how to expand the network, how to refurbish the network, taking into account all the complexity of it, which namely it means looking at vast geographic elements where the quotas are important, where the details are important. The fact that pipes have to respect the thermal-hydraulic settings, the physics of it, but that also needs to be mixed with economics valuation. And the final result is something that needs to justify investments, which normally goes into return on invested capital indicators like net present value. So in order to do this, a tool has been developed that started on a GIS tool, allows to manage all existing and potential pipings and users. Of course, a mix of different plans, both existing and potential. Every element in the map needs to be editable and manageable from the user, and this needs to be characterized both from a technical viewpoint, but also from an economic standpoint with financial parameters in order to manage a diversity of scenarios. So this these are examples of studies on the thermal hydraulic simulations. This is actually coming out from UpgradeDH, because investment decisions require the capacity to set up a scenario, but then also compare them with a lot of efficacy. Maybe the most interesting point regarding a tool like this is that it doesn't only allow us to simulate how this heating pipe piping system works, but also allows to choose the best possible potential expansion strategy. What you see here, I mean, all the stuff painted in red is potential pipes and potential users. And it is the system itself that out of the many potential combinations will choose the one that maximizes the net present value. Just imagine that if we have 100 potential users at hand, the number of possible combinations is 2 to the n, which is a number with 33 zeros behind. So a huge number of potential options, but the one that optimizes the net present value is one, and our system is designed to guide the user towards that optimal solution. Of course, that means that choosing the right pipes to be built, the right customers to be connected among the possible ones, and also deciding on the minimum diameter of the pipings. Of course, we all know that these decisions are not deterministic, so there are parameters to be set by the users, like acquisition curves or contemporaneity factors, so that different options and I mean, a safe area can be designed to actually make the best choices regarding expanding your network. Good point is that this is actually can be, in terms of optimization, can be used both for new network development, totally new, also network expansions, and that's important because that means that the impacts on the thermal hydraulic system of new customers is automatically taken into account by the system in terms of pressure drops, pressure requirements, velocity, etc. And a very interesting case that has been managed in the past with this tool was actually on a completely fully saturated network to understand what customers of those who were not exploiting the full contractual power could be reduced in order to actually create a sort of virtual power plant made of the savings from these customers in order to link more customers to the network. So lots of different options throughout the value chain of a network, but also lots of simulation capabilities that span both on the technical side and on the economic side. The model itself actually looks at the full cash flow and the financial investment strategy for each scenario. So lots of very interesting comparison can be made. I will finish off because time is very strict with a few examples of the application of such systems. One is actually with A2A Canal Servizi in Milan. It's a good example of something that starts on a digital world, but then is brought down to earth. The case of A2A was to understand how best to allocate heat, capture customers throughout the backbone of more than 6 kilometers, an interconnection between two existing systems, very densely populated, lots of a huge number of potential choices, and they were supported. Actually, they're using this system as a service to improve and actually allocate their commercial efforts in the best possible way. Maybe a very interesting outcome of the experience with them is how the tool was not only used by the engineers, but also by the people in the marketing and commercial department, with those who knew the market that could embed in a single tool commercial and technical decision making. We're speaking about UpgradeDH, so it's fair to say that we exploited a tool like this, and we used it in 2 places. One is Marburg in Germany, and the other one is in Lithuania, in Čepulis. In both cases, we looked at different design options and expansion capabilities. In the case of Šalčininkai, it was also good to apply the same tool to analyze refurbishment strategies and, in fact, also the study of a low temporal secondary route hypothesis, very versatile tool. And I will just finish, since my time is almost over, with maybe a more prestigious project for the UN environment, the District Energy Initiative. A tool like this, connecting physical and economics, was actually used to study the opportunities of interconnections in the Belgrade system, which is one of the largest in Europe and the world. Looking at a variety of challenges, switching off of fossil fuel plants, new customers, new pumping stations, big new connections to renewable sources. I think it was really put to the test, but it still provided the basis for very interesting decisions that lead the process towards a better and greener systems in the upgrade, exactly in the spirit of the UpgradeDH project. I'll stop here. I'm available for questions now or later. I will leave Aksana to facilitate.
Thank you very much, Matteo. Yes, indeed. The audience can ask questions by typing them in the questions box on the right-hand side in the panel of GoToWebinar. So please, you can type them along our presentations, and we will get back to you, Matteo, if there is anything. Thank you very much. And as Matteo mentioned, Lithuania is one of the participating countries in UpgradeDH, and I have the pleasure to give the floor to Evaldas from the Lithuanian District Heating Association, who will also present the status and the challenges they are facing in Lithuania. Evaldas, the floor is yours.
Hello, everyone, once again. One moment. Can someone confirm?
Yes.
Screen? Is everything clear? So I am Evaldas Čepulis from Lithuanian District Heating Association, and our association gathers 40 companies in Lithuania. And today I would like to present our country's sector and our activities focusing on distribution area. So first of all, district heating sector in Lithuania has an annual production of 9 terawatt hours. The heat losses in the networks are 50%. The used heat production capacity is 3.2 gigawatts, and the heat is supplied via almost 3,000 kilometers length of pipelines. And what's to be noted that district heating networks, basically without any exceptions, are installed in all cities and towns. The share of district heating is constant over the past decade and stays around 57%. This number is third in Europe. Our sector also in the past decade had a significant jump in renewable energy source usage from 23% in 2011 to more than 70% today. The vast majority of this fast transformation to renewable energy sources was consisted of elimination of natural gas with biomass in heat production. This year we are expected to overcome the 80% renewable energy source usage limit since 2 large-scale CHP plants will start working into our largest cities. As the district heating production and sales in our country is on a constant decrease because of ongoing renovations of buildings and warm winters. This means that the majority of district heating pipelines are becoming more and more oversized. This graph shows an annual replacement and expansion of district heating networks in Lithuania. The statistics were gathered using perennial data of all district heating sector. This graph together indicates the tendencies and approximate lifetime of the pipelines, which based on this analysis show that it's in between 30 to 40 years. For leak detection, our companies often employ thermal imaging and other technologies depending on situation. Corrosion speed identification technologies are also used by some companies. Sadly, not all companies are interested in to monitor such parameters, especially the smaller companies. Today, main failure in the old part of the networks are caused by an external corrosion. This picture shows typical construction of new pre-insulated pipelines in the which was inserted into an old concrete channel, so you can get the idea what kind of work companies are doing while changing the pipes today. Lithuanian District Heating Association is also participating in Baltic Smart Asset Management project, and as the name indicates, the purpose of the project is to develop methods and collaborate between countries on smart asset management topic. And as we all probably know that the main drawback of district heating is the capital need and inefficient operation, thinking about heat losses, which expressed in economic terms would mean would result in low return on capital, and it also requires a massive replacement need. So in order to solve these challenges and boost district heating efficiency and reduce the capital need, asset management is one of the most needed processes. It creates environmental benefits and more affordable heat to end consumers by utilizing the current infrastructure for longer period. The Baltic Smart Asset Management Project activities focus on digitalization solutions of distribution networks, the development of conditions and monitoring, utilizing the latest ICT tools for data-driven predictive maintenance. The current trends of talking with the company CEOs, the current trends are looking like that the most of all the ducts transmit half of the energy volume it could. Operational efficiency is better or soon will be better in most cases than selling more heat. And the distribution grid could live way longer than 30, 40 years if modern maintenance techniques would be employed. So in order to improve the return on capital employed, we need to reduce risks and in operational and capital costs. So it could however it's obviously hard to balance between expensive old pipe replacement, which gives negative effects on third parties, and between aging pipes, higher leakages, higher heat losses, and higher repair costs. There are different asset management techniques, and the simplest ones are being done constantly by most of the companies. Other techniques require digitalization and installation of various sensors, and maybe even usage of artificial intelligence solutions. Basically, maintenance methods of the network could be split in four categories. So the first one, the corrective maintenance method, more or less are being done by all district heating networks after any failure occurred. In Lithuania, for example, and probably in many other countries, planned testing is performed for the network, which provokes failures in weakest parts during the warmer period of the season of the year, in summertime usually. Some companies might choose to change pipes and prevent failures. However, the preventive method highly increases the capital costs. And today, what modern companies, modern district heating networks are looking for is to use various sensors and technologies which could accurately identify the condition of the network, and the company therefore would be well prepared in this matter, and it would significantly reduce the operational and capital costs. And with the help of digitalization and possibly artificial intelligence, the data-driven predictive maintenance would be employed in more and more networks, and it would kind of be a next stage in asset management. So if we could accurately predict the condition of the pipework, we could optimize and selectively refurbish the network. This would ensure the expansion of utilization, and the whole process would minimize the losses, fuel costs, operation costs, failure risks, and the capital, most importantly, the capital need. So in other words, the predictive maintenance would help to detect and locate corrosion or thermal wear of the pipes well before it's burst, and therefore we highly increase the utilization of the network and eliminate the risks. This is the area in which our leading companies would like to improve, and are always looking at various new technological solutions that appears in the market. So thank you for your attention, and if you have any questions, please type it in the chat where Aksana mentioned.
In the questions box, indeed. Thank you, Evaldas, for these impressive pictures and an interesting overview of measures to improve old heat distribution and piping technologies. Thank you again. There are no questions for the moment, so we will go on with our next presenter, Sebastian, who will also introduce you to a very interesting research project about district heating pipes restoration. Sebastian, the floor is yours.
Thank you very much. So you should be able to see my screen.
Yes, all is fine.
So I will give you a short presentation of an ongoing research project. The research project is part of the work I'm doing for the AGFW project company, which is part of the German District Heating Association, with around 500 members and up to 250 utility companies that are members of AGFW in Germany. And the project I want to give you some short information on is dealing with the question if there's a possibility to do some district heating pipe renovations or refurbishment with so-called cured-in-place piping systems. It's supported by the Federal Ministry of Economic Affairs and Energy in Germany, and we got a lot of partners in this project with experts from district heating area, but also from the liner technology area. And we have a big consortia, and we are on a good way currently, but of course we are just in the beginning of the technology for district heating, so it's not on a commercial base at the moment, but we are looking quite positive in the future to have this opportunity for within the next decade, let's say. What is the motivation behind this research project? So in Germany, and I think it's pretty similar in many other European countries as well, the district heating networks and especially the pipes were built around in the 15th and 16th, and they are coming close to the end of the expected technical lifetime. And one of the biggest problems is that the historical grown district heating networks are grown with the cities, and the center of the district heating networks are also in the area where you have the center of the city, and these places are usually not very easy to dig up holes in the heart of the city center. So this is the reason why we're doing this kind of project, to get an idea if we could find a new technology to have an opportunity instead of replacing a piping system, which is usually very expensive, and especially if it's in kind of unplanned pipe exchange, it's also very cost intensive. And from now on, I'm not aware of lots of different opportunities for short-term fixing options, and that is the reason why we're going for this research project. To give you a short idea how the system in general is looking like. This is a system that is coming from the technology of sewage water, so it's still very well known, but not very used to, or it's kind of very challenging to adapt all the requirements for district heating in that case. But the basic idea of this technology is to use a kind of flexible tube, which is added in glass fiber and added some viscous resin, and as kind of inner and outer coating, there's some foil or tube in the inside and the outside to have this kind of viscous resin in the middle, saved from going somewhere else than you want to have it. And usually there's some protection foil at the outside. Why is that? Because here's kind of explanation how the technology is working. As you can see here in the picture, in the middle there's some simplified pipe, and it's somehow broken. And in this case, you're not able to dig a hole right under the tree. So the idea of this technology is to dig before and after the broken area, and have the chance to pull in this kind of flexible tube in the existing pipe. And the next step is to pressurize this kind of flexible tube, and then use ultraviolet light to harden the system. So after this kind of hardening process that is looking like this in reality, you will have like a very rough or a very straight pipe inside your existing district heating pipe. So it's not replacing the old pipe, it's more or less an additional tube that's fixing some issues in the old pipe with a kind of new layer inside the pipe. For finalization, you have to close or connect the old pipe to the tube system, and you using some special part for this, which is kind of challenging in the district heating area as well. And then you have the opportunity to reconnect the grid. You have to make a leak test, and then you can enter the pipe back into service without fully replacing the pipe and digging the whole area. So just two smaller holes in the beginning and the end of the renovations area. So this is what we expected when we started this project, is that we have this kind of well-known and reliable technology for buried pipe systems in general, which is already used for many years in the sewage water. And since the last few years, there were a lot of developments to use it for pressurized pipes and also for gas and freshwater pipes. It seems to be a very time-saving alternative instead of replacing a full area of pipes. And it's kind of, as you see there in the pictures, some kind of lower impact in the affected area, especially when you think about streets and buildings that might be crossed with a piping system. And depending on the boundary conditions, it could be some kind of more cost efficient than other opportunities, and also somehow eco-friendly in the end. But Still, this sounds very nice, but of course, there are also some challenge and limitations of the system. For example, if you have like very bad piping conditions, here's some very, very bad example, which is not part of a real district heating system. It's from a steam system, a corroded pipe. And if you have this kind of situation in your network, you will have a lot of problems, but you can't fix it with the system I presented before. So it's not usable or not helpful for all problems you might find in district heating systems. But also there are some special ones for pre-insulated piping systems also. Of course, the temperature level is kind of very challenging and different from like sewage water or whatever. So this is development we made during the project time from now to identify which resins could be used to have the high level temperature in the systems, and also especially as challenging for the systems is the typical district heating pipe problem, or let's say it's not a problem, but a classical district heating system could have a variation of diameters and a small connection to big pipes all over the network, and this is kind of challenging for the system, or for the cured-in pipe system. And depending on the idea where you want to use this system, is like have a big influence on the effort of the development that needs to be made until the time you can use it on a commercial basis. Of course, it's very important to know if this cured in place pipe system could be a short-term or long-term solution. And somehow it could also be helpful if you have some limitations in the maximum temperature level. But also it's depending on the diameter of your pipes you want to use that for. Depending on this market share of the piping diameter, it's like more or less challenging to have a business model to develop this technology to the end. And also when we will finish the project, we are going now to have a first demonstration case with a testing scenario and doing a real using a real district heating pipe and insulate it with this kind of inline layer. And we will find out in the end of the project if it's worth to, or if it's suitable to use this kind of technology for district heating. But on the other hand, it's an step afterwards to identify if there's, on the technical limitations we were identifying during the project, if there a market share that is high enough to go for further development to bring this kind of technology on a real business case level. And this is the short introduction to this kind of project. If you have any additional questions afterwards, you're very welcome to send me a mail or give me a call. And thank you very much for your kind attention.
Thank you, Sebastian. I would like to remind that you can type your questions in the questions box. We will continue, although it's a pity not to see the nice puppy anymore, but we will continue with Peter and his expertise about modern pre-insulated pipes. Peter, the floor is yours.
Yes. So do you see my screen?
Yes, you just need to put it in show mode and hide the GoToWebinar control panel with the orange arrow.
So
yes, perfect.
Now it should be there. Okay.
Yes.
Thank you. So I will just jump directly into the presentation. First, I will elaborate a little on the word modern. So for me, modern is that we work in direction of what is inside the 4th generation district heating, becoming to 5th generation as well. So it's focusing on low heat loss, so low heat loss as possible from the pipe system. It's also focusing on making sure that you keep the same properties of the lifetime during the whole lifetime of the system, especially when it comes to the heat loss properties. It's about having information on a running basis about what is the condition of the pipe system, especially if water will come into the insulation and you need to be able to make some repair immediately. Then it's also about making a modern choice of pipe system. And when I say modern, then I mean a choice based on total cost of ownership, where you evaluate what is the best choice seen over the lifetime of the system. And then, of course, making sure that you already, when you are in the planning phase, think about how can I secure my assets. Because when the pipes are in the ground, then you have to live with the consequences that you have of your choice during the lifetime. And what is green? For me, green is as low heat loss as possible, which will lead to the lowest possible CO2 emission possible. Green is also making sure that the materials that you use in the pre-insulated pipes can be recycled at the end of the lifetime of the pipe system. But it's also actually using recycling materials when you produce new pre-insulated pipes. So basically thinking about circular economy. So what is the right choice of pipe system if we look at it from a total cost of ownership perspective? To make the right choice of pipe system, you have to evaluate between all the different choices you have. And if we look at the dimension of pipes at a relatively low dimension, but pipes that everybody have in the system, then you can do single pipe and you can do twin pipe. All you have in 3 different insulation series. And you have pipe systems where you actually have a diffusion barrier that will secure that the insulation properties of the polyurethane foam will remain the same during the lifetime. So all in all, that leads to 12 different choices actually for the same project. So it is a complex situation to make the right choice of pipe system. If we look at it, how does it actually look today in Europe, and we look at single pipes, then we can see that 60% of the market, what is installed today, is actually CS1. So 60% is the worst insulated pipe system available. Think about that. Twin pipe is the pipe system with the lowest possible heat loss. And twin pipes represent 35% of the market of installed pipes today in the dimensions where it's possible to make a twin pipe. In Denmark, that figure will be 70%. In Poland, it's around 5%, and in Italy, close to 0%. And lowest possible heat loss, and thereby also CO2 emission, will come from a twin pipe system. What we see today is actually that a lot of energy companies, they do what they do because that is what they always have done. And I think that has to be challenged in the future. We have made a model where we can calculate on a project and evaluate on all these 12 different possible choices you can do on a project, where we evaluate on the total cost of ownership, and on the investment part, so the capex, we have included the investment in pipe materials and the investment in contractor work. On the operation part, the OpEx, we have included the heat loss cost. We have, for example, not the pumping cost included, but the pumping cost for the 12 different scenarios will be the same. So that is what we have included in our model, where we can calculate total cost of ownership. So this is basically the predefined project that we are evaluating on. So dimensions that everybody will have in their network. Then we have calculated the total cost of ownership for all those 12 different scenarios. And important is that the energy company will give the assumptions for the calculation. So they will give the assumption for the material cost and for the contractor cost. They will give the assumptions that is used for calculating of the operational cost, so the heat loss. Especially the period of years that we are calculating on, but also the price of energy. We recommend always that when you make a total cost of ownership calculation, then you should calculate on at least 30 years. But we actually see a trend that energy companies calculate on much longer time, some even on 70 years, when they evaluate which system is the best system to choose. So they should do this for all the possible scenarios, and then they should make sensitivity analysis. So do analysis on different time of periods, do analysis of different price of energy, and see what is the right choice for me. Because when you do the choice and you put the pipes in the ground, then you cannot change it. Then you have to live with the consequences for the rest of the lifetime of the system. So in this case, with these assumptions, the optimal district heating pipe would be actually the best insulated district heating pipe. But it all depends on the assumptions. It could also be something different. To compare the CO2 emission, I've just chosen to compare between three of the pipe systems. So I have the worst insulated at the left part of the picture. It's single pipe series 1. And compared to that, the best insulated pipe system, where you also have the lowest CO2 emission, will have a CO2 emission which is 64% lower, and the heat loss will be 64% lower as well. And then you of course have to think about the assets, and you have to do that already in the planning phase and in the installation phase. So not only when the system is in operation, then of course you also have to think about the assets, but you have to start thinking about how to maintain your assets already when you plan the project. And then it's important, of course, to choose the right materials. It's also important to educate those people who are installing the project, installing the joints, that they are educated to do the job they're supposed to do. And then the energy company has to make supervision of the job. And we see often that this is actually not done. Then you should always choose an active surveillance system where you will have immediate information if something is happening with the system and you have moisture in the system, and then you can react. By doing this, then, and it's actually very, very simple guidelines, then you will have a system where you will have flawless operation and you will not have any breakdowns. If you don't do it, then you have the risk of what you will see on the pictures, and you will have the risk of expensive repairs, breakdowns, and actually lower lifetime than you originally expected of the pipe system. So what kind of information from the network can we have as it is today? Then we can have information from the surveillance system. From that, you can have information about if water is coming into the insulation. You can even have information about if water is coming from the outside of the pipe or if it's coming from inside the pipe from the media. We can have information about wells, about flooding in the wells. You can have some information about temperature and pressure with the right equipment. And then as a management of an energy company, then of course you need information, need kind of a dashboard from where you will have the total overview about your system to see where do I have some places in my system where I need to do some corrective actions in time so that I will avoid to have expensive repairs. How does the future look? What is modern in the future? I think total cost of ownership must also be modern in the future. It will be modern always. And it goes for any type of pipe, any type of media pipe. So I actually do not think about what is the type of media pipe, if it's steel or plastic. No matter, you need to make the total cost of ownership on different pipe systems as well, and you need to do it on different insulation shares and so on. Again, in the future, be green and think circular will for sure also be modern. Then we will probably see much more digitalization of the pre-insulated network. So we need to get information from the network so that the energy company can optimize the operation of the network in respect of temperatures and pressures over time, and in that way also reduce the heat loss of the system. And all of it has to bring value to the energy company. What will be the vision for the future about green solutions? Again, total cost of ownership will also be green in the future, because looking on investments over a long time, that will give the choice whether you will have the lowest possible heat loss, and that will benefit in the way that you will have the lowest possible CO2 emission. Then, of course, use of recycled materials, we will see more of that in the future. And we actually have started that journey already. We participate in different funded projects about using recycled polyurethane foam and recycled plastic from industrial waste. So you can say the long-term vision is actually that new pre-insulated pipes is produced from 100% recycled materials. That was it. Thank you.
Thank you very much, Peter. I will invite all presenters to turn on their cameras. And we will take another 5 to 10 minutes to address the questions that were received during the webinar. So let me start with the first one, which was to Matteo. Is there also the possibility to consider decentralized feed into the grid? Does it consider also the pressure changes and control strategy of the pumps?
Okay, thank you very much. The tool as it is already considers multiple sources. Maybe in one of the pictures in the presentation you could detect that, but that's not a big issue. Of course, we are right now looking with some partners the possibility to go towards much more extreme cases, prosumers cases where with ultra-low district energy systems, which have some specific elements. It would be interesting to discuss this further. This system as it is not fit for that, but it's a very good start to eventually go in that direction. Regarding the pressure changes and control strategies, of course, this is a strategic design tool, so we are not looking at the dynamics during the day, but we look more at peak or particular situation snapshots. But yes, we've used the tool many times to understand how best to size the pumps in order to make sure that there are no critical points in the network. So it's more a strategic tool rather than an operational one, but it is very useful also to understand where and what size of pumps would place along the network. I hope this is enough. In any case, you may have my contacts if you can get back to me.
Definitely. The presentations will be published and you will be able to find contact details of our speakers in them. Thank you, Matteo. Next question was to Sebastian. What is the expected lifetime of such repaired pipes?
Yeah, as is a research project, this is one of the questions we need to find out in detail. So the general technology, when it's used for sewage water, for example, it's possible to use the sewage water pipes for multiple decades afterwards. We asked the inliner experts what they expect for district heating boundary conditions, and they were quite positive, thinking about ranges of 3 to 5 years or even more. But I think on a realistic level, it's very much depending on the operation mode of your district heating grid, and also on your, especially on your maximum temperature level in the grid. But it could be also a nice opportunity to repair your pipes, even if it's just with a lifetime to reach the end of your current heating period, so you can have a planned and not so stressed opportunity to exchange your pipes during the summertime or whatever. So we will find out in the research project, or we try to find out what will be the lifetime afterwards. And of course, we're looking forward to have a lifetime period as long as possible, but we will see what's coming out from the tests that are currently running for the materials under temperature stress.
Thank you, Sebastian. Looking forward to the results. Next question was to Evaldas. What kind of renewable energy is used in Lithuania?
So as I mentioned in my presentation, Lithuanian district heating sector is expected to reach 80% renewable energy source limit this year. And the full structure of the sector would be around 50% of municipal solid waste. So it's considered as renewable, or in some cases partly as renewable. Around 70% would be biomass, and what's left would be mostly natural gas. So it's mostly biomass with some parts of municipal solid waste from this year.
Thank you, Evaldas. Are you also looking into solar heat integration?
Yes, we are looking at these possibilities, but mostly it's not feasible in today's economic situation in our sector. Actually, companies are looking at solar PV panels, but not solar heating technology, because that's how the market push the companies today.
Yes, but I know that under UpgradeDH we were considering these possibilities. And thank you. Next question is how to drill a new connection in a twin pipe system. I believe was for Peter.
Yeah, but, you can on a twin pipe system do hot tap drilling same way as you actually do on a single pipe system. So basically, there's no difference. You just need, of course, a joint solution to cover it all afterwards. But the hot drilling itself is the same if it's single pipe or twin pipe.
Thank you, Peter.
I don't know. I think I had a question from yesterday as well.
Yes, indeed. We received. Yes, yeah. Please go ahead. There was a question from one of the pre-registered of the participants. How is the use of plastic pipes developing in the DHC market against traditional steel pipes?
Yeah, for sure we will see increasing request for plastic pipe system as temperature level in district heating systems in most countries probably are decreasing. So when temperature is decreasing and we go more for low temperature district heating, then we will see an increase of plastic pipe system. But from my point of view, you shall always evaluate still, compare steel to plastic also on a total cost of ownership perspective. But one of the interesting perspectives by plastic pipe systems is that we probably see in many countries lack of skilled steel welders, and that can be somehow solved if we increase the share of plastic pipe systems. So there will for sure in future be a development also for new plastic pipe systems.
Thank you very much. Another question came in to Matteo. Does the software leave the choice of the pre-insulated medium pipe material, steel versus plastic?
Well, in fact, what kind of technology to use is a parameter in a way, both from a technical and economic viewpoint. So you can decide what kind of potential pipings to put and place your scenario with one of the others. Of course, the subtleties of the choice is up to the user, but it allows to put a number of parameters, so the technology itself is not dictated by the tool, which suggests how basically to get the right balance between diameters, flows, pressures, and how much to expand the network. That's the real purpose of the tool, rather than a technological choice. But of course, only we can dig into the actual need of where last.
Thank you, Matteo. I would like to wrap up with a question that also came during the registration. The participant was interested in an overview of measures to improve old heat distribution and piping technologies from the 80s, for example. So I believe some presentations already gave answers to this question, but would you like to wrap up maybe with your final word about improving heat distribution and piping technologies?
Should I say a few words? Okay. When you think about updating or renovating old pipe networks, it's of course a question about making your priorities. So you need to do the exercise and find out where do I spend my money, and there's a lot of exercise you have to do. You have to look at the repair statistics. What kind of joints has been installed? I mean, what year was it installed? What is the age? There's a lot of things you have to evaluate, and I think there's actually a lot of literature about what to do. And then basically, I think what entities have to do is really to consider how much should they actually renovate each year to make sure that they'll not push a big problem ahead of them. I know of energy companies that say if we will keep this level of renovation every year, then we should expect our network should last for 900 years. And that's of course a problem, because then they push potential problems ahead of them. So everybody should basically make a plan about how much should I spend actually in renovating, and renovating can be different things, of course.
Thank you, Peter.
Maybe I can add also something. So yeah, I think this one of the additional question on that is how to identify the current status of your piping system, and this is pretty much related to the historical usage of the pipes. So we are also dealing with some ongoing research project on a national and also international level to have opportunities to identify the real status of your pipes, because basically when there's no leakage or anything broke and you don't have to make a new connection, you don't be really aware what it, or you're often not really aware what is the real status of the pipe. So you have like statistic models or whatever to say, okay, after this time period, we're expecting so much time is left over before they reach the technical end of their lifetime. But to identify or to get an idea what is really the current status of district heating pipes that are buried under the ground, it's kind of very challenging, and another nice questions to identify new research potential.
Thank you, Sebastian.
I may say a couple of words. I would just point out that any strategy requires, I mean, as Peter said, it's a matter of understanding how much you need to be able to detect the problems, eventually adopt, I mean, strategies for predictive maintenance, like the ones that Evaldas mentioned, or if within a renovation campaign you want to understand better how best to renovate with planning tools like ones that I mentioned. So I think that there's a vast range of options that we've outlined here, and possibly a few more are already in the repository of the UpgradeDH project. So please go there, and we'll be happy to discuss that further.
Thank you very much. That was quite a technical webinar, and we will continue with addressing different topics of district heating and cooling modernization with the UpgradeDH webinars. I would also like to mention indeed the image raising campaign that we've launched under the UpgradeDH project. I hope you can see my presentation. Yes. So this campaign targets normal people, general public. We will try to promote modern district heating technologies. We will try to improve the perception of district heating by sharing success stories and best practices of district heating modernization. So please, if you want to participate, you can also use the hashtag DHCitizen on social media and share your stories. We will also continue with the DHC Plus talks in general. So next topics on our agenda are less technical and less project related. So next week we will talk about who we are, meaning the DHC Plus team and what we do on our daily basis. And then we will have the online ceremony of the International DHC Plus Student Awards. And at the end of June, we will have another webinar, a more policy-related webinar about maximizing use of waste heat. You can find our schedule, the links for registrations, but also the recording of all webinars and presentations when they are available on the webpage euroheat.org, DHC Plus events, DHC Plus talks. And with that, I would like to thank everyone, first of all, our speakers for making the time and also sharing their favorite coffee mugs with us. And we will stay in touch for the future events. Thank you. Stay safe, and we will see each other quite soon. Thank you very much to the audience for your attention, and have a great day. Goodbye.
Bye.
Bye.